Am I live? Testing.
Am I live?
Cool. So how am I going to do this? I should be able to see the chat behind the terminal. There we go. So, there is a game called Shinju where you are clicking on these little shells, or maybe rocks, I don't really know what they are, but you click on these things and you're trying to reveal where the gold medal is. But if you click on the wrong shell, it'll show you a hint. So, like this hint says 5, so you go down 1, 2, 3, 4, 5, and this whole 5 perimeter around it has the shell that has it. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 in this square. It's only these 3 possible ones. So it's 3 away from this one, which since that's in a perimeter, it's 1, 2, 3, 1, 2, 3. It's kind of here, but only the one that is in this 5 ring is going to be the shell that you want. So it's kind of similar to Minesweeper. That's the concept. So all of these grids are 9 by 9. You can see I kind of worked with it here, kind of typing it out in text form, and then I started writing code, and I thought, hey, why don't I make a live stream where I'm programming this? So that's exactly what I'm going to do. So first, little trick there to prevent it from auto indenting it going inward like that. It's really annoying. I'll show you. If I had just pasted it into a normal viz session, this would have happened. This is just a bunch of stuff to fix. So just close that. So here's what I have so far. Yeah, I don't even have anything working yet. Just some help text. I'll kind of go over it real fast. So we have our includes for studio and stdlib. stdio has your your printf, your puts, file IO and stuff like that. stdlib has things like exits and malloc. I don't think I'll need malloc. And then we have some. Our grid is going to be one-dimensional, and then I have some transformation macros here. So I have our grid width, which is 9. And then our grid 2D, which takes our 2D coordinates and turns it into a one-dimensional offset of the array, which will give us a pointer. And then we also have our one-dimensional to 2D-dimensional, which takes a single one-dimensional offset and turns it into a pair of coordinates. And that is this right here is a cast, where I'm casting it to an interarray of 2. It's a C99 feature. And this is where I was writing code and decided, hey, why don't I start streaming? This is when I was writing this edom here. Because I need to figure out what the values are going to be for the yeah, this is fine. You don't need to see my face. Although it does help me express what I'm trying to say a little better because I can use my hands. So maybe I will. Maybe I will. There it is. I didn't turn off the light. Okay. Not cool. I dug my light source back out. So now I'm not shrouded in darkness. Okay, so what I was saying. We have this so this here is an array of strings. It's just describing the usage checks, and we see I terminated it with null, and this is used in the usage function. So instead of having to do 1,000 puts statements, I just do it in a loop. This is much better in my opinion. Because then if I want to add text to the usage, I just add some stuff. And then we have our main function, which currently just checks if the number of args is 1, which would be the program's name. And if so, then you didn't feed it any arguments, so there's really nothing for it to do. So it just prints the usage help. Otherwise, it parses the args, and that's basically where I'm at. So right now I'm deciding on grid values, because we need to be able to store the hint in a cell, but we also need to be able to store these special values, like if it's been if it's blank, or if it's been flipped, or if it's been ruled out. Those are basically the main values. So I'm going to use -1 and -2 because we need the positive numbers 1 through 8 in order to, because you have a 9 by 9 grid, the maximum distance you can have from anything, from any one node on there is going to be 8. So those are going to be my values. Now when you make a static, when we make an array at file scope, it will always be initialized to 0. Any object at file scope will always be 0, whether it is auto, extern, or static. This is guaranteed. So this is all zeros. So now we're doing the Parsers function, so we need to go through the argument list, which, as established up here in the usage help, is going to be a list of coordinates. Just hide that so I can free up my screen real estate. do it like that. And what we need to do is we need to take the argument and decode it. So right now that's simple if it's a one-dimensional, but we do need to detect if because there are 9 rows I need, right? It's A, B, C, D, E, F, H. Yeah. So I'm going to need the string libraries. I'm not using my hands to gesture as much as I thought I would, so I'm just going to turn off the face cam and turn off the light so I can see better. And I can kind of see the chat through the translucent terminal. Okay, so we're going to use stir to find the offset. Char const res equals stir. The stir is row-to-lim, and the chur is arg v I 0. And if res equals null, then we're just going to take we're going to set grid to D to make it consistent. It's going to be expressed in chords, and it should be chords, not a pointer. So grid of grid to the A2I we're just doing the straight coordinate in this case, because if res is null, then that means that it was not found. But I also do need to make sure that I'm casting it correctly. So we also need include C-type, because this has macros and functions like toUpper. Which will preserve its value if it's a punctuation character or a number, but if it is a lowercase number, for example, it will change it to the capital version. Okay, so we got that. And now grid of A2I of not res, but arg v I, because we're taking the whole argument in this case and we're interpreting it as a number, which is the offset in the grid. We're going to place the value, and we're going to place GV unknown. And at that point, we also might as well continue out of that to the next one. I guess it's coming together. Next, if this didn't happen, then we found a result. So Lovely. I love when OBS just disconnects like that while I'm in the middle of talking. So if res is not null, then we found a result. So that means that the first character is a letter from A to I. So what we need to do is take the result and its offset from row dilim. And this will be, we'll store it in a size T for convenience. We don't want to do that up there, we want to do that up there. And then what we're doing is taking grid of A2I, no, of grid 2D, because we're taking 2D coordinates now. So in 2D coordinate land, that offset represents our Y coordinate, and then the second character represents our actual our X coordinate. So we're going to take A2I of argvi plus 1. So what that does is if you have a string like hello, and then you add 1 to it, what the code sees is this, because you've shifted the pointer. You've shifted the pointer 1 forward. Pointer arithmetic is great, isn't it? So A2I of argvi plus 1 to get the rest of the string after the first character. That's our X coordinate, and then our Y coordinate is, I was just looking at the macro to make sure that it isn't evaluated more than once. Our Y coordinate is our offset, which I don't even really need the offset because that's also not evaluated more than once. So res minus row dilim. This is actually a good opportunity to point out something about macros, is if you notice, I have wrapped all of the parameters in parentheses in the macro. And this is important because if you have a macro like you have a macro like this, and then you call it with 5 times 7 and 2, then what this will expand to is actually 5 times 7 plus, yeah, that's a bad example. Let's do multiplying, because I'm trying to show it breaking the breaking operator precedence. A times B. So if you have add 5 plus 7 and then 2, what it's going to do is expand to 5 plus 7 times 2. But anybody who knows operator precedence knows that this will be interpreted this way, which is wrong. That's not what you wanted. You wanted 5 plus 7 times 2, not 5 plus 7 times 2. Those are two completely different results. With this, what you're going to get is 5 plus 14, whereas what you wanted was 12 plus 12 times 2. So 5 plus 14 is going to give you 19, and 12 times 2 is going to give you 24. Two very different results. This is why we wrap our parameters in parentheses in macros, because this safely expands to 5 plus 7 times 2. It's important to keep that in mind when writing macros in C, because the C preprocessor does not understand C. It only knows how to expand macros, which includes splicing files into other files. The CPU processor is not a smart processor. And that's one of its biggest advantages. So now that we have that established. Another thing though is that if you have something that's evaluated more than once, so I'll give another example, define square. Let's say, and of course we'll wrap those. So here the x appears more than once. And this can be tricky when you have, for example, if you have square n plus plus, or maybe even just plus plus n, something happens to the argument that makes a side effect, then what's going to happen is that's going to expand to plus plus n times plus plus n. This can also happen with function calls, etc. But somebody who knows particularly a lot about C might recognize this as undefined behavior, and that's because it is. You see, when you have multiple modifications and reads happening to a variable within one sequence point, which this is all in one sequence point, then you have undefined behavior because there's no way to know how the compiler will interpret this and emit assembly or machine code to carry out the task. Any compiler is allowed to do anything it wants when it sees something like this, which makes it undefined behavior. So that's another kind of pitfall you can have. So if you have something where the arguments appear more than once, you might want to just use a function. And there is a way to write functions without having a function call overhead. And to do that, you would write the function like this, and then include the inline static. Static makes it invisible to outside modules, and inline will ask the compiler to inline it directly into the calling function, which of course if you have optimizations on it absolutely will. But then now if you have, the only drawback here is that you have to include the type, but now you can just return your x times x and it'll work. And it'll be spliced in the same way that the macro would, because the macro is just literally x times x, and then this is being inlined in, so you remove all the overhead of calling the function, pushing the arguments to the stack, and then pushing the return value onto the stack before unwinding it using registers, etc. Instead, it's all done directly. So those are considerations to keep in mind when you're writing macros. Now where was I? So we have grid 2D, A2I, the second part of the string for x, and then res minus rodalim for the y coordinate. Because if the match was right here, then the pointer is going to be to this first character. So when you take that result pointing to the first character and subtract this rodalim from that, you're going to get 0 because they match. But if it's higher, then you're going to get something else, which like for E, for example, it's going to be 4 because offset 0, 1, 2, 3, 4. A bit complex, but now we have a way to, oh, we need to actually do something with that L value. So the grid will default to all GV blank, which is represented by a dot. And here you're taking all the arguments from the user and setting those coordinates to GV unknown, which is, now we have our actual, parser in place. So if I make a rendering function, let's just hide that. So it's render grid, and we don't need any arguments. And we can take advantage of our 2D transformations now. do that for now. What we're going to have is character. Well, we need the header first too. So for every row, that's going to want to 0, 1, 2, 3, 4, 5, 6, 7, 8. And then for every row, we're going to want to you might as well share that row delim. Space, and then the argument to that is row delim of y, because we're doing the y coordinate. And then we're printing the cell value, which is grid 2D of xy. And then after that, just put a new line. I can get rid of those. Let's test it. So here's your usage text. And we're going to go and use the example 2, 8, 9, 14. And it didn't print out anything. Right, because I'm telling it to print out negative numbers. What am I doing? Well, that's inconvenient. So maybe I will do it the way that I was originally going to do it. So gv blank, and we'll just let this be an enum. And what instead we will do we need a way to mask this, so the value I'll use, since it's out of the way, will be oh, it's 10. So if it doesn't have the grid end mask, then it won't be interpreted. And I do it that way because that will, we got to keep in mind that the grid will default to all zeros. So in parts args, we're now going to, we're going to leave it the same. But if we are going to put a number in, for example, then what we're going to do is we're going to OR it with the grid end mask. So what that's going to look like is you're going to have so if you're inserting the number 7 and you want that to be interpreted as a 7, then you mask it with this, which would look like grid and mask or 7. And when you're checking if the grid and mask is there, you're doing cell and grid and mask. And if so, then you're doing the cell which can also be expressed as grid and mask -1. So if you do that, then that will do it will do this mask against your number, which will isolate only those bits. For now, we're not doing that though. We're just leaving it alone. And now when we do need to take account for that. We do need to account for that in render grid though. So if we'll say int cell equals grid plus grid 2D hello xy. So we need those brackets back since we have multiple statements inside here. If cell and grid and mask, then I could just do the ternary like I was saying. So cell and grid and mask if it is greater than 0, or if it is non-zero, it will be truthy. So if we have the mask, then we're going to isolate those bits and print that out. And no, we can't do that because of the format. So never mind that. What we will actually be doing is so we'll take the value directly and print it as a number, and otherwise we will print the, and we do need to dereference the cell. We can't be using a pointer here. So that should work. We're taking it as a character in this case, just interpreting it literally. And we'll test it again. I need to compile it. Okay. Oh, I know why. Because I'm just asking it to print a really small. So it is printing them. It's just printing control characters instead of what I actually want, which is the whole reason I took row_delim out of the function and put it at file scope was so that I could do this. There we go. Not what I wanted. What am I doing? That was for the row header, not for the contents. So what I need is static char const cell cell special, and I'll just say grid value char to be consistent with the enum grid value. So for GV blank, the symbol is dot. For unknown, it's question mark, and for ruled out, it's X. Now, we're not going to use row_delim as the source. We're going to use grid value char. There we go. And now we have a renderer. We need to test with some numbers as well. I can just do that organically as I'm writing this. Okay, so this is going to be a REPL, or a read eval print loop. So after parsing the args, render grid is only going to be the first stage of our loop. Okay, that's main done. So we need a run REPL. So int static environments. Remove function call overhead when you can. So run REPL. And I don't think we needed any arguments for that now. Okay. So the first thing we're going to do is render grid. And then we need to get input from the user. And then we need to parse that input. So that's basically what our loop looks like. And based on the parsing of the user input, we need to return a value. And what's going to happen, so the reason why I put that in a while loop is what run REPL is going to do is it's going to return 1 or 0. If it returns 1, that means keep going. If it returns 0, that means stop. So that's basically the interface. Static inline, oops. Get user input. And static inline int parse. I'll leave that open for now. So this will definitely be void. Not int. Well, we'll figure out. I'm going to leave that blank for now. So getting user input, we're going to need to read a line of input from the user and parse it. Okay, so we already know what to do then. Okay, so when you make a static array in a C function, it's a function scope, and usually when you make an array, it's not guaranteed to be initialized to 0. But for static arrays, it is, because it has a lifetime that matches the lifetime of the whole program. So because of that, it doesn't die when the function exits, it doesn't get rolled off the stack, because there's a constant reference to that somewhere in the program that it refers to whenever it uses this object. For this reason, you can return a static object from a function without invoking undefined behavior. However, there is a little drawback to this, in that you can only return 1. What I mean by this is that this is created at load time before the program runs, and it's initialized. So I can't, if I initialize this with something, like I can't initialize this with something dynamic at runtime, because that goes against the static. But if I return this and then I modify it and then in another call and then return it, so I have two functions that both have gotten a return value from this function that returns a static object, and then well, basically those two functions will receive the same pointer. That's the crux of it. So it is a constant pointer to a specific place in memory that never changes. It's never automatically allocated at runtime. So if you make a static array and then return it, keep in mind that there is only one of it. And if you return it multiple times expecting to be able to use different copies, you need to actually make a copy, because if you don't, then you're just modifying the same object over and over again, and then you have data erase. For here, this is a REPL, so the only thing that's going to see this buffer is going to be parse user input. So I don't need to worry about that. It'll be fine. Now, what we need to do is make an int. And the reason you have to use int, stop, okay. The reason you have to use int instead of char for reading a character is because fgetC and the family of functions that it has to do with, they can return a character from a file, or they can return EOF, which is not a character. Specifically, EOF tends to have the value of -1. That's not guaranteed, but it is typical. And officially, EOF has a value that is outside of the range 0 to FF, 255. It has to be outside of the range because this range here is character range. This is the range of a single byte that can be stored in a file. And EOF has to have a value outside of that range so that it's unique, so that you can test if there is an error, or I guess in this case, the end of file condition. Because this can't, when you are reading in terms of multiple characters, for example, fread, what happens, how it signifies that it ran into the end of file condition is that it just returns either equal to or less than the number of characters requested. So there's no way to detect it. The only way you can detect it is by checking the actual end of file condition flag. And because the file object is opaque, that means that you're not meant to know exactly how it's implemented. Trying to take an F and then doing a internal buffer based on something you saw in the GNU debugger, this is wrong. Don't do this. You got to use FEOF. FEOF will tell you if you have the end of file condition. That's the standard portable way of doing it. Anyways, that's why I use an int. Because if you use a char or an unsigned char, you cannot store EOF. And you'll see this if you, for example, try to read a binary file and you do this loop with a signed char. Then when you have a character that is equal, that weird funny Y character with the dots above it, it's what the code page on Linux uses for the code point for 255. That happens to also be -1. So there's a collision there and you run into the end of file condition even though you didn't actually, so you only read a part of the file. That's why you use int. That's why all the character functions return int. So while ch equals get char, we're getting it from standard in, so we can just use get char, isn't equal to EOF. So we got a pointer to that, and we'll just store it in a stack. Store the character. We also need to check for a new line because we're trying to just read a line. And I can actually further generalize this. So static inline size t. Read line. And what we're going to do is we're going to take a char buffer and a max size, and that should be fine. Yeah. here's another thing. This might be confusing to some people. What's happening here is these are both unary operators. So unary operators are usually parsed right to left. So in this case, you have plus plus being parsed before the star. So what this will do is it will increment the buffer pointer, but before it will return the value of buff pointer before it was incremented, and then it dereferences that. And because the dereferenced pointer is an L value, I can assign that. So this is a common idiom for pushing things like a stack. And the reverse of that for popping is this, which is also an L value, but you tend to use it as an R value. So we're pushing the character, not the buffer. If you do that, it'll just get truncated to from some gigantic value and have a bunch of the same weird nonsense character appearing over and over again. So we're pushing the character into the buffer that many times, and when we're done, well, we need to check some things. So, like I said, if FEOF STDN hello, then well, yeah, just return 0. Because that would happen if you hit Control D, which on the Linux terminal will send the EOF. It just sends EOF. So you can use that to terminate. Watch, I'll show you. And then I hit Control D, it ends it. So you can see it echoed what I was saying, what I typed. We'll also do this if there was an error. And now we can return buff t minus buffer. So the offset of the buffer from the base of the buffer. And this will give you the number of characters that were written, or that were read. And then we have our readline function. So we can get rid of a bunch of this and instead size t and read equals read line buff 4096. Oh, and we also need to, I knew I was forgetting something. I need to make sure that I don't read more than 4096 characters. So yeah, we'll just cap it there. Then return prevents us from reading too many characters into the buffer. And what you might notice is that this buffer is not 0 terminated. That's because I'm actually using the size. So we read line buff with the limit of 4096. So if our buff pointer reaches an offset of 4095, then we've reached the end, and we will stop reading at that point, even if we haven't encountered a new line. Which, I mean, that's absurd to reach a line that is that long, but, you know, you gotta be safe. So whatever happens, it'll read your line, or it'll break it, and then it'll give that the number of characters that were read from standard in into it, not including the new line. So we're explicitly leaving that out. Now that we have our user input, oh, I can just, I can actually get rid of that user input function. So what we're actually going to do here is, static char. because then every time the run REPL function runs, we have the same buffer instead of having to allocate a new one every time. It's a small optimization. Not that we're trying to focus on optimization here, but and size t and rev. So instead of get user input, we're just going to nred equals read line low from line buff, using that line buff as the buffer, and 4096 is our limit. And then we return parse user input, and we have our input, so it is line buff and 4096. No, not 4096, what am I doing? And red. It's the whole point of getting it. It's important that we print our feedback before we get input from the user. But you also don't want to be scattering variable declarations all throughout the function, so I have them hoisted up here. So we're going to get rid of this function. It's gone. We're gone. And we're going to go ahead and give our arguments, which are a and size t. Let's get called len. Okay, so now we need to figure out what kind of input we're expecting from the user. And make like a mock-up of what it would look like. Maybe have give a coordinate in either 1D or 2D form. I think that's what I'm going to do. So yeah, so instead of parsers, we need a function to transform a string that contains either a 1D or 2D coordinate to a 1D coordinate. So static inline int, because it is a 1D coordinate, it's an offset, so it's going to be an int. String to chord. And char const chord. The reason I make the char const is because I don't expect to be modifying the string in this function, so I'm making a promise that I won't. The const is a contract. I'm telling callers of this function that it is okay to, for example, call this with a string literal, which if you attempt to modify a string literal, you will invoke undefined behavior and your program will crash. Of course, I'm legally obligated to mention that crashing is not the only thing that can happen from undefined behavior. Anything can happen. That's why it's undefined. But generally, that's what will happen. So string to chord will basically do the same thing that parsers was doing in the loop, which is taking your chord string, char const res equals char. I'd probably just copy most of this. Let me check chat real fast. I don't see. Yeah. Okay, so char const res equals char row to lim to upper argv I 0. If res equals null, then grid we're not doing that. So if res equals no, if res equals null, there is no match, so we're returning a 1D coordinate. So return a2i of argv I. So this simplifies. So I saw a way that I could clean it up, and I'm doing that. I didn't try to make it super clean from the beginning. I do tend to do that, but otherwise we return our 2D coordinates using this formula. Yeah. Which takes the a2i of the character afterwards, and then takes the first character's offset from the row delimiter and subtracts that from the base to get our offsets. And now we have a function that we can reuse. So grid of skr to chord argvi equals gv unknown. Look how simple that is now. Damn. Okay. So parse user input. We still need a prompt. Show prompt. And we're taking arguments. Okay, so I'm still trying to think of how I want to take the input, because I know I want to take the coordinate first. But should I do it in 2 stages, or should I do it comma separated? Yeah, I think I'll just do it like that. Enter a coordinate and a value separated by a comma. F4 means that the shell at F4 has value 7. No. String file. Yeah, looks good. So okay, so we're gonna have to do this since we're using delimiters other than null. Isn't there a memture function? Yeah, okay. So memture takes a string, character to look for and a length. Okay, so enter road limb, 2 upper, hey, and then. And then res equals no, blah, blah. Oh, and I need to change the name of that because it's no longer argvi, it's chordster. No, I can use stir here because the stir isn't chordster. The stir in question. The stir in question is rodaling, and we're trying to find a single character from chordster. If res equals null, then a2i of wonder. Okay, I need to make my own function then. Static line int mem2i char const stir and size t lem. And then what we're doing is I could just do this. Char copy len, yeah, len plus 1 equals, no, we'll do that. I can initialize it to an empty string, but there's really no point to that. Let's let it be uninitialized, and we will mem copy stir len. No, we need to copy it into copy using stir len. Am I using that right? Is it destination, a source, and a size? Yeah. So we're making a temporary string which has that, and then we're copying only those characters of our string into the temporary, and then oh, and of course copy is len, null terminate it so that a2i won't freak out. And that looks good. If this were C89 or the original NCC, that would be illegal, but C99 has VLAs, which is what that is. So we're doing mem2i instead, and using chordstir plus 1, and okay. We need Sterling delim. So that's to take a char const stir and a char delim. And what this will do is it'll do the same thing as stirlen except So once stir I equals it to lim, we terminate and return I. And since this is returning a size C, let's just make that a size C. And it has to be outside. Okay, so I don't even need to for loop here. So, yeah, there we go. Let's just give it a better name, since we're not in a for loop. Stir then delim, chord stir +1, and the delimiter is a comma. And then the same, no, this is different. A2I chord stir, mem2I chord stir +1, stir then delim, chord stir plus. What am I doing? Okay, price is null, what does that mean? It means that there was no match, so we need to use the whole thing. So I can just use A2I. No. I still need to use mem2I. Just delimit it at the comma. And then for grid 2D, that's where I'll use chord stir +1. Stir then delim, chord stir +1, comma. Wait. I made another goof. Because this is supposed to work with both the inputs that this function can receive are either of the form, H4 or 17, or the same thing, F4, comma 6, or 17, comma 6, comma 5. It's supposed to work with all of these without actually knowing, because what it's basically it should be seeing is only this. That's how we reduce complexity. And by using stirlen delim, I'm making that part visible when I don't want to be doing that. So this is for the caller to figure out. So mem2I with len -1. And there we go, that's much simpler. So we're getting the second character of chord stir, and we're doing the length -1. And then res minus row delim. There's no reason for that to change, so. Okay, we succeeded in not breaking the function. Now we just need to find everywhere that was called. And update the function. So in this case, we're just going to pass argvi with stir len of argvi. Couldn't be simpler, because that's the default case. But then in parse user inputs, right? Yeah, okay. Okay, so now what we need to do is size t sets. Hold on, I gotta do something. I'll be right back. I'm back. I wasn't aware that people were still in the super group chat. Thought that was abandoned. Here we go. So where was I? I was I just finished factoring this out, the stir to chord, so that I could parse the user input, which is going to be of the form, you know, like F4, 6, for example. Now, why do I need the offset again? Let's just start over. Size G. Sublibin. No. Okay, so right. So offset is our 1D coordinate. Stir to chord, and we're using the buffer and stir lim delim of. Yeah, maybe I will do a quick shut up. How do I? I didn't really make an announcement channel. This doesn't have anything to do with devil daggers. Oops. Doing a programming stream. There we go. Where was I? Here we go. So again, as a reminder, this is what I'm programming for. It's making a solver for this game. And I might, in the process, just end up re-implementing the game. Who knows? But here's where we're at. So we have the coordinate, comma, and then value to set it to. So we're taking stir to chord using stirlen delim on the buffer. And the delimiter is comma. And that should work. And maybe I should just size to chord one. Brief. So then we'll do a chart. Nah, we won't do that. What do we need though? Use mem2i on buffer plus chord len. Which will select the string after the comma. And the length of that needs to be I think. So that should be fine. So we have our coordinate and we have our value. So if grid at offset, hey, if grid at offsets, check chat, still lurking. Yeah, I still haven't rejoined UDBus. Not sure who Skronkle is. Take a shot in the dark and maybe you're this guy. I have no idea. Hey Roxer, how are you doing? If grid offsets, well, first we need to check. I don't think we really care if you're setting a grid. Yeah, whatever. Okay, so if grid offset and what was that macro called again? Grid and mask. If it is a number, then I won't stop you from doing anything. Just warning. And cell at coordinate. And the coordinate value is offset. Okay, but now we need to also check if grid offsets in this case we will actually cancel it because and we'll return 1. If grid offset equals GV ruled out, And then finally, if grid, well, if grid at offset is unknown, then that's actually the intended case. So finally, we're going to set grid at offset. And go ahead and put these before the returning case. This is a matter of consistency. Finally, after we get past all that, we're going to set our grid at offset to grid and mask or value. But we're not done yet, because after this, so basically if you set like this cell here to a 2, so that's going to be set, but we also need to scan the perimeter around it and invalidate every single question mark that is not in that ring. So in this ring. But for now, we can just test to see if it actually fucking works. So where's the R key? Okay, we have 3 warnings. Format U expects unsigned input. I have size T. Okay. So 155, 158, and 161. Now we're going to go ahead and just make the makefile now. So to make our target, what is this called again? The actual target. Shinju solve. And the requirements for this is main.o. I don't think we really need to do anything. We'll just go ahead and set our C flags. Just catch extra stuff. And I might as well also add fsanitize address just for funsies. I have my audio on, right? Okay. And save, please. Clean. Just so it doesn't get any funny ideas. Make main and make clean. Okay. Comparison of integer expressions of different signedness on line 137. The buff b minus buffer can be expressed as a size t, and size is a size. Okay, what is the problem? Just cast it. Okay. Shinju salt. Hello, hello. I have a linker error. And function usage. What are you talking about? I notice the call to exit is missing. What happened to that? Oh, ASAN is address sanitizer. You know, maybe we're supposed to do it here. Ah, okay, so I was using fsanitize equals address wrong. Okay, so let's... and use the example of 2, 8, 9, 14, and we'll enter a coordinate of A2, and we'll set it to 7. It works. A2, 5. And you get the warning. It says cell at coordinate 2 already has number value. And you'll see how this works when I do B5. Set to 3. And then I'll do B5, 3 again. And you'll see warning cell at coordinate 14 already has number value. So B5 and 14 are synonymous, and the reason for that is because if we take this starting at 0, go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This whole thing is a one-dimensional array. It's just being wrapped using some math. And the reason for that is because one-dimensional arrays are a lot simpler to handle in memory than 2D arrays, because with the 2D array you have to allocate a pointer, and then you have to allocate a pointer for every pointer in that pointer. Because a two-dimensional array is not some kind of magical matrix, it is an array of arrays. And you have to allocate every single one of those arrays. Whereas if you use a one-dimensional array and just use some math, you can allocate one single array and then just offset into that using your math. Got a negative size param. That happened when I did the exit. So in read line, if we reach an end of file condition, we return 0. And I don't think I ever checked that, did I? Check that in file condition, and if so, then return 0 to indicate that we need to quit. And that should fix that. So now if I hit Control D, there you go. Okay. And we've confirmed that the number logic works. So after doing that grid set, what we need to do is to take that spot on the grid and then step that number of spaces outwards in a perimeter around it. And those are the safe shells. Because so like in this game, I'll show you an example run. So we'll click on this shell and it shows 3. So that means that in a ring that is 3 spaces away from it all around, only those shells in that ring are the one that contains the goal of the level is in that ring and nowhere else. So 1, 2, 3, 1, 2, 3. Right? Yeah. Everything in this ring here, these are our choices. Anything that's outside of the ring is invalid. So 1, 2, 3, 1, 2. Yeah, that was the metal right there. So the way that works is if I choose this, you can see 7. So you know that it's in a ring of 8 around this and a ring of 7 around this. And the shell would have to be in a place where those 2 rings intersect. Because like if you have something that intersects with the 8 ring, which is anything in here, but is not in the 7 ring, then that's not going to work. So that would rule it out. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So these 2, even though they're in the 7 ring, they are not. They definitely don't contain the metal because they are not in the 8 ring. So it's kind of like Minesweeper. Just need to figure out how I'm going to do this. Let's do that. And we'll use the grid as our data structure to figure out like what has and hasn't been done, because that information is already in the grid. So static inline. Well, maybe I should just return grid update. Just keep on bouncing it along functions. And this will also return int. My reasoning here is that if there is only one cell left that is the possible candidate, then I might as well just at that point render the grid and quit, because then you'll only have one question mark and all the X's will be there. So from that point I could just return 0 from here. So we need to start grid W times grid W if grid W, grid I. That's another way this is convenient. If you just need to do some general operation on all the cells in a 1D grid, you just loop through it like you would a normal array. The only reason in render grid that we use the 2D coordinate system is because we're doing different things depending on whether we're at the start of a row or at the start of a column. So at the start of a row we do different things. So we could do it this way, or we could do it one-dimensionally with a check if I is at the boundary of a row. It's just needlessly complicated, so that's why I'm doing it like this. So if grid I and grid n mask is definitely going to need multiple statements. But actually, if not invoke a 0 comparison, just check falsiness. It's more idiomatic. So if not grid I and grid n mask, that means that the grid n mask bit is not set, and in that case we can skip this iteration. Otherwise we need to grid update invalid at. Wait. I need to take them all into account. Okay, so we'll have a list of valid indexes. And a size yeah, okay. The approach we're going to take is to filter this list down, but first we need to build it. So we're going to start by just including all of the indexes, but only if the value at that grid cell is not blank. or ruled out. So if we're going to have it pass a gauntlet before it actually does that setting. Since they're going to grow at different rates, I need to because if we don't do it that way, then we're just going to have an array that, like, it's going to have holes. And then all those holes are just going to be gibberish. That's not what we want. That's not what we want. We don't want holes. We want the array to look like this. So, the first part of the gauntlet is this is difficult. If grid I if it's been ruled out or if it's blank, then it's definitely not valid. And the loop is going to have to be separate. Like, we're not going to be able to just run through the let's do that for so we're not going to consider shells that have already been flipped and have a number as valid, because the thing we're trying to come up with is an answer for which cells are candidates for the answer to the puzzle. So if grid I and if it is a number, then also continue. Otherwise, we store. So basically, only if it's an unknown type of value. So the question marks, those are going to get stored in our list of valid candidates. Their coordinates, at least. And after we make all those modifications to the list, we reset its size. And then we go through the list again. This time we're going through each grid cell. And only if we find a number. Only if we find a number, we're going to check around. But how are we going to corroborate those two things? So let's say you have this 3, and when you make your list of candidates, I'm going to set this back to a question mark in this. Yeah. So when you make your list, the list is going to be basically 2 and D4, and that's going to be the entire list because everything else is numbers, blanks, or invalids. Let's make something else. Just so we have something we have to grab onto. E4. This is our valid list. And before we process the 4, we process the 4 and we look at every cell around it. You would have to make a list of all of the valid indices around. So like for 4, for D0 with 4, the ring would be starting from here and going down into D4. You have to make like a square around it and exclude anything that's out of bounds. And then go through me work this out. So our list is going to be A4, B4, C4, D4, E4, F4, G4, and H4, H3, H2, H1, H0, along with a bunch of others, but those are invalid because they either clip off the side or they go out of bounds. So it gets filtered down to this, and then this will get further filtered down. And that'll get further filtered down again. So we're looking at A4, that's blank, so we're going to filter that out. B4 is also blank, C4 is also blank, D4 is not blank. D4 is valid, so that gets included. E4 is also valid. F4 is ruled out, so no. and you know, all these others are ruled out. So that's the list you end up with. Okay, so you have a filtered ring, which is D4, E4, and you have your candidates, which is A2, D4, E4. And we'll go through each candidate and make sure that they're actually in that filtered ring. If any are not, like A2, then our candidates shrink because we're now filtering it, and it becomes D4, E4. And then when you repeat this process for cell B5 with value 2, then our candidate list shrinks to just D4. And the only candidate that is in that list is D4, so then our candidate list becomes. But we also need to take the opposite of that list and mark those as ruled out. So basically the candidate list at the end of this processing would become a list of protected indexes or indices. And when you then go through the entire list, okay, I have my algorithm. I'm going to call that the ring. You can also call it the perimeter. Our valid IDXs are a list of filtered valid indexes where the goal is. And we're filtering it down to only the unknowns. Things that haven't already been ruled out. But we also need a list of all of our... Yeah, I'm going to make 2 lists. And I'm going to assume that you can't have more than 10 turns. So although, is this really faster, or can I just... I think I'll just go through. The valid list is something that's going to mutate as the algorithm goes on, so it's something I need to keep track of, but the numbers to look around, they're already in the grid, so I just look at that. So first things first, ring equals get ring, not rind. We're not talking about fruit here. So ring equals get ring. And it's going to be at that index. Yeah. Now what is the maximum size that a ring can be? Since the maximum distance is 8, let's see. Because if you have 8 at any point, then it's going to go around starting here, but it's only going to cover half of the perimeter, because it would have to go around the whole thing. And since those are out of bounds, they don't get included. But if you start at the center of the grid at E4, and that's prime for the perimeter to go around the entire thing. So you have 9 plus 9 plus 7 plus 7, 18 plus 14, which is 32. Okay, just to be on the safe side, I'm going to take that and double it. So my buffer size is going to be 64. Static inline int. I shouldn't be modifying the ring, so make it const. And get ring. Maybe it'd be a good idea to start annotating the functions that they're supposed to be doing. Solid offset. Gets a ring round solid offset. Ring only includes unknown. Wait. Yeah. Unknown values, as those are candidates. So our origin is where that is. And I can finally use my grid 1D macro, so int static int ring since I'm returning an array, maybe what I should do my throat is really dry. I should get some water. I'll be right back. Be right back. I'm back. Okay. So there's our ring. And I think what we're going to do Have I actually used this macro anywhere? No. Maybe I'll do this. So of course 2D. Oh, it does the Y first, actually. We use it with the struct. So y equals c2d.y. Y is less than c2d.y. It's going to be less than or equal, because we need to include that as well. For value. Grid offset and grid and mask -1. No, I need to formalize this. So we need we need to start at our origin, and we need to go around in a ring. So we should start at our y minus the number, x minus the number. That should be our starting point, and it'll go down. But we need to also filter out the in between, because again, we only want the perimeter. So y equals c2d dot y minus value y is less than or equal to c2d.y plus value. Yeah, okay. And for int x equals c2d.x minus value, x is less than or equal to c2d.y plus value. No, it's supposed to be a semicolon. Plus x. And I actually only use the y. Good thing I caught that now rather than 2 hours from now. After a long session of debugging. Okay, so this will give me a fill on the entire square surrounding the words, the square surrounding the origin. I just need to exclude anything that's not on the perimeter. So if trying to think about how I determine that. Let's make some more variables. X left, X right, Y top, and Y bottom. Y bottom, Y not bottom. X left, X is left, and X right. If I can learn to spell. Okay. So if X is greater than X left and X is less than X right, and Y is greater than Y top and Y is less than Y bottom. So if all 4 of these conditions are true simultaneously, then that means that we are not on the perimeter, because X can be in between these 2 extremes while still being valid, because the Y value is still on the extreme. And the same thing with Y, it can be in between these and still be valid as long as the X is at one of the extremes. But if all 4 of those conditions are true, if X is in between the extremes and Y is in between the extremes, then we're in one of these in between squares. So that should be sufficient to continue. And now that we've ruled that out, what now? We're trying to get a ring of values, so now we're looking if X is less than 0 or Y is less than 0 or X is greater than grid W, or but is it valid to be equal to grid W? If the W is 9, no, it's not. Y is greater than or equal to grid W. So if any of these conditions are true, then our coordinates our coordinate is out of bounds. So we're just going to go ahead and continue there as well. What else do we need to filter out? We need to filter out anything grid of grid 2D XY if it make another variable but if I do this before that, then that's not valid because that's undefined behavior. There we go. Make sure it's in bounds first, then get the value, and if cell value, if cell value is equal to the shell in the ring is only valid if it's unknown, so we're just going to check if it's literally equal to GV unknown, and if it is, because if it has a number value, then it's going to be greater than 16, whereas GV unknown is only 1, I think. Doesn't matter what its value is, it's just what matters is that it's below 16 because it lacks the mask. So it can only equal GV unknown if it lacks the mask. If it lacks that extra bit. So if cell value is unknown, then we get to include it in the list. So ring p ++ equals we don't want to include the cell value, we want to include the coordinate. So grid 2D XY. Okay, and then after we've done all of that, we can just trying to see if they're left with OBS disconnected again. I'm back. Okay, so we have int ring p, which is the pointer to the ring. That's what we're using to populate it. And we have our coordinate, our value, and then 4 boundaries. And we don't have length now. However, we don't need it because ring p. Yeah, just set it to -1. So we'll use it as a sentinel to say that this is the end of the array. And then we'll return the base ring. We'll just do an if0 comment. I don't know how well the function works, so I'm going to test it. So we're going to printf just going to go ahead and hard set grid I'm going to set that to 5. And get our ring coords. So now I'm writing code to walk the ring. This is just to make sure that it's coming out correctly. Hey, I sure do love OBS disconnecting over and over again. I guess we're looping through the ring, and for every one of those, we're just going to no, we're not going to get too involved. Let's do a simple CSV. So do that on ring I to get the value. We're just going to print the raw numbers. And then after that, puts okay, we'll just set 2 to 2. Something broke. And get ring. That just points to the 0 page. Got a seg fault. Movie's got that offset 14 equals 5 out. I'm sure that's printing, which is fine. Yeah, ring chords. The reason it didn't print out was because of IO buffering. It hadn't printed out the line yet because it was still in the buffer. Because it was waiting for there to be a new line so that it could write it out all at once. And that never happened because the program crashed before it could. So that's why it appears that the ring chords never gets printed. Let's go over this again. Oh, I didn't initialize ring P, that's why. Silly me. So I was working with a wild pointer there. I wonder why I didn't get warned about that. Because I'm initialized. Notes on line 199. Oops. And that happened because I didn't include the comma. It's a user error. And something I can handle later. Okay. So you see it set the 2 to 2 like I asked, and then offset 14 equals 5, and the ring chords just equals 9. So where's 9? It's right here. 1, 2, 3, 4, 5. That is in fact 5 spaces away, and it's in the perimeter ring. So that is correct. So the only bug that I had was that I accidentally left that pointer wild. This is what it's, there are a couple types of pointers that have special properties. You have void pointers, wild pointer, dangling pointer, and a null pointer. These are all things that are useful to know about. A void pointer obviously is a pointer of type void, which is a generic pointer in C. A wild pointer is a pointer that has not been initialized. A dangling pointer is a pointer that's been freed. So if you use a use after free is basically using a dangling pointer. But there's another type of dangling pointer too, is if you take like a char foo and then you return foo. Once you're outside of that function, using using foo is undefined because it is also a wild point, is a dangling pointer. Because this gets deleted from the stack and deleted from the program, which just means that it kind of lets it go and anything else can just grab onto it and start using it. So if you return an array from a function, it's a dangling pointer, and then a null pointer is obviously null, which is usually, but not guaranteed to be, defined as void 0. It's just the value 0 as a pointer. But again, it's not guaranteed to actually literally be 0, but it is guaranteed to compare equal to 0, which is some weird semantic distinction in the library, in the standard for the language. I don't know if anybody actually uses it, but that's how it is. The main point of null is that it's supposed to be a unique pointer that no other pointer will compare equal to. So a null pointer is a valid pointer. It's just not valid to read or write to it, but it is valid. So if you ever hear me say a specific type of pointer like that, now you know what I'm talking about. What can we characterize that as? It's like x left and y top both make a top left, yeah, and then the bottom right. So I can actually just call it a rectangle. So x0 and then int x1, and int y1. So we start with x0 and y0. So c2d.x minus value, and then y0, which is c2d.y minus value. And then their bottom right corner, which is c2d.x plus value. And just copy and paste this. Change it minus 2 plus, and there we go. And replace every instance of x left with boundary.x0. And this with boundary.x1. And this with boundary.y0. And my bottom with boundary.y1. That's getting really annoying. Okay, I just deleted some code here. Stop. I just deleted those because I replaced them with a boundary rect. So I'm just going to go ahead and test compile that, make sure it still compiles. Yeah, good. Doesn't crash and it detects 9. Cool. Okay, so now what are we doing? Get rid of all that. I don't even want to look at this, so I'm just going to delete that too. So we need to make a list of our valid candidates and then go through each ring. And for each ring, for each candidate, we're checking if that candidate is in that ring. And if not, then the candidate gets filtered out. And we do this for every cell on the grid that has a number. And this will have a compounding effect where only the candidates that were in every ring are in the candidate list. And that's the list that we protect when we're going through the list one more time of all the cells and marking every unknown as ruled out. Because if anything is not in that filtered candidate list, then it's ruled out because it's not. We already ruled it out. I'm sure there's a more performant way to do this, but that's what I came up with. So we are going to get a ring. No, that's not what we need. For int I equals 0, I is less than grid w times grid w. You might ask, why don't I just use grid w times grid w up here instead of valid len? And the reason for that is because my intent is to be going over the list of valid indices. not to be going over the entire grid necessarily, even though it starts out that way. It's important to do this because it gets my attention across that I am specifically talking about the list of indices. This thing here. That this loop is specifically in terms of that. So it is very deliberate that I do that. Anyways. So I equals 0, I is less than grid w times grid w plus I. What was in that commented out code, by the way? Okay, it's literally what I have. Okay, so I'm just gonna alright, we need that valid len too. So going through every one, we're making sure to only, we're ignoring everything that does not have the grid and mask bit set. So anything that is not a number is ignored. And this allows us to get our ring for I, which will get a filtered ring around, only including things that are in bounds and on the perimeter and are unknown, not ruled out. And what we're going to do is we're going to go through our valid indices, and for each one of them check if it is in the ring. If it is not in the ring, then we throw it away. So j equals 0, j is less than valid len plus j. I was just trying to think if there was a way I could flatten out this loop a little bit, but I was getting into a premature optimization mindset, so I just stopped. FYI, stream keeps running even when OBS is crashing. This was the first time the stream had to reload for 2 seconds. Yeah, to your perspective, you probably just see the stream pausing for a second and then, buffering and then skipping ahead. And I know that, because when the stream gets rendered and saved to YouTube, it's going to cut out all of that blank time that wasn't having anything being streamed to it. So, to your perspective now, it just appears as the stream is buffering and then it comes back. But when the stream gets uploaded to YouTube, it's going to just appear as time. It's going to appear as if time just skips ahead. And I know this, so I stop everything I'm doing when I see that notification that OBS stops, and I wait for it to come back. Okay, so valid IDX J if I'm not doing a third level of looping. Static inline int ring has okay, what this is going to do is going to go for int I equals 0. I also need the ring. Ring I isn't equal to -1 plus I. If ring I equals offset, right, because we're storing the offsets. So if it has this, then we return 1, return 0. If we exhaust the whole loop without finding a match, then it's not in there. If ring has offsets, ring, and our offset is valid IDXJ. If ring has offset, or I guess we only care about if it doesn't have the offset. Well, we're filtering. How am I going to do this? Okay, guess I have to do that. I'm going to do a back buffer. Valid P. We're just going to reuse valid P for the purpose of populating. So ring equals get ring, and then valid P equals valid IDX back buff. And so it's just temporary. I think we can do it all in one iteration, so I might be able to just move it in here. Size T. I don't know. I'll just valid len. And then int. Just so I have a consistent interface here. I'm not fucking around with a bunch of pointers. Get rid of that black buff. Okay, so what am I doing? If ring has offset, then back P plus equals. Not really use the backline then. Back P plus equals. Equals valid IDXJ. So we're only including that index if it's in the ring. And we'll go through that. And then what we're going to do is well, valid IDX. Oh. test source and size tn is the number of bytes to copy. Okay. So our destination is valid IDX, and our source is back P. No, not back P, it's a back buff. And the number of bytes is back P minus back buff times size of right? Yeah, because it's the size of an integer. That many bytes. We're talking about bytes, we're not talking about elements. And since integers are multi-byte quantities, we need to factor in the size. So this should copy our new array into our old array, and then what we can do is take valid len equals, I could just do it before here, valid len equals back, not bfac, back p minus back buff, and just replace this with valid len times size of back buff, size of an element of back buff to be specific. We can just get rid of that. Then we don't have to care about what happens to back buff or back p because we already copied them over. And the list has been filtered down. So we go to the next iteration until we find a grid and mask. Get that ring. We look through the ring to see if for each valid IDX that appears in the ring, if they don't appear, they're discarded. If they do, they're put in the second array and then copied back. And this happens until we've exhausted everything. Okay. Now for int I equals 0, I is less than grid w times grid h. No, there's no grid h. What am I doing? Plus I. And if I if array this array has, and our array is going to be valid IDX, the length is going to be valid len, and the thing we're looking for is I. If that is true, then we're skipping because it's protected. So let's just make a quick array has, and I might be able to change ring has offset to be written in terms of array has. Okay, so for int I equals 0, I is less than len plus I. If array I equals value, don't want to be doing 2 loops, so I could just do 1. It's not quite duplicate code. This does it in ON rather than O2N, even though O2N isn't a thing, but still. I was going to get the length of the ring and then just call array has using offset as the value. Thought I saw a typo. Okay. So if our we're going through every index in the grid, every 1D coordinate, and we're checking if that coordinate appears in our valid indices array. If it does, then we skip that. Otherwise, okay, grid. Well, we need to meet some condition first. If grid I only if it's unknown. If it's unknown and it does not appear in the valid indices, then it's ruled out. So and that should be it. Now before we do that that loop, let's do some sanity checks. If valid len equals 0, or no. You've ruled out puzzle is impossible, no candidates left. There is only one. I'll do it after the loop. There is only one valid candidate left. Can I be reminded? There's only one candidate left. No. Just trying to figure out how to write this. Only remaining candidate is at. Yeah, there we go. And I need that delimiter. It's row delim. Oh boy. Yeah. Okay, row delim. It's also render grid since we want to modify it. Okay, valid IDX 0. Let's do that. Row delim candidate.y candidate.x. (282) or 202 and 251. Or else 251. Okay, so we'll say that our target is over here. So starting at A2, that's going to be 1, 2 away. So at A2, we're going to set this to be 2. Let's say that we activated it in the game. Okay, and you see that it marks these as invalid. We're going to also set B5 to 1, 2, 3, 4, 5. Oh, never mind, it already quit. See that? Look at that. Only remaining candidate is at B0, which is right there at B0, quitting. And then it shows the grid with the invalid things marked. Everything's all marked up, and you can see there's only one question mark. Maybe I should rework that so it appears below where the prompt would be. Because I just wrote that code and it managed to confuse me. Not the code, but the running program. So 2, 2. There you go. So instead of a prompt, you see only remaining candidate is at B0, quitting. Wow, that's I just want to see how it looks on stream. We're getting nested. It looks good. Okay, good. I was worried for a second that this whole time I've been typing code that like looks all pixelated and blocky because it's being rendered at a different resolution. Okay. So let's go ahead and test this with a real game then. Accidentally went and pulled up a meme. Game, here it is. Oh, that's kind of annoying. I don't want to mess up my command prompt. Okay, so I have another SSH window here, and I can stop. Okay, so we're going to feed the level in via the arguments, and what we have here is A1, A, no, not A1, A0, A0, A1, 2, 3. Yeah, 3, A4, 5, 6, 7, 8, and then B1, B2, C1, C2, D1, D3, 4, 5, 6, D8, and then A, B, C, D, E, 1, 2, 3, 4, 5, 6, 7, F1, 2, 3, 4, 5, 6, 7, 8, G, 1, 2, 3, 4, G5, H0, 1, 2, 3, four, 5, 6, 7, and then finally I1, 2, 3, 4, 5, 6, and I8, and we have our map. So we're going to set at 0 using 8, and at I1 using 7. And you can already see it's working pretty good. So our valid candidates are only along this line here. So these 3. So we're going to just choose one. Maybe this one. Oh, I got it. I wonder what happens if I do I80. Warning, puzzle is impossible, no candidates left. Okay, so yeah, I guess the distance of 0 isn't quite valid. So it was 0, 8 I and I8 0, but I1 7, and then F8. So that'd be 1 2 3. So, and you see only one candidate remaining is at I8 quitting, and then points directly at that. So my program works. Of course, the user input handling is not very polished. It is very, very, very strict. If you do not go by the format, it will crash. Oops. So if I don't follow the format, like if I just type 3, you can see that it crashes. And the reason it crashes is because it expects the specific format. See? So one thing I could do to polish it up is to, well, probably still have it aboard if you put the wrong input, but at least tell you why. Or I could, not be lazy, and if there's no comma at the end of the string or anywhere in the string, then do another prompt. So the way this could be turned into a game is there's really not many steps from here. All you have to do is generate a random grid, choose several random cells to assign as unknown, and then add a variable in there to be your answer for the puzzle, and then add a limited number of guesses, because you can see that right there, it clicks left at 4, and let the user guess. So instead of doing coordinate comma value, just type in the coordinate, and then it would flip it and then tell you what the value is based on the distance from the answer, and then reduce the number of guesses left. And if the user runs out of guesses before they uncover the cell that has the answer, then they lose. There's your lose condition. Otherwise, if they manage to and of course the code for marking cells is invalid. It would have to be just removed. So it would know all that internally. Yeah, going from here to a functioning game, it wouldn't take that much. And I might actually do that, because this game is actually kind of fun. So anyways, that's the stream. If I probably will be putting this on my GitLab. So if I do, then it'll have the exact same name that I gave the program. So Shinju SLV for Shinju Solve. Later.